Okay, so let's solve the exercise. So let me state the exercise again. So we have jobs. Every job, there is now a processing time, and there is also a wait, WI. The wait, you should think about it as how much how much you are getting paid for this job. That's the right intuition of what's going on. And what we are trying to minimize is the weight we are computing. We want to compute the permutation pi of the jobs such that the wait time for the I job, which is the sum, multiplied by the weight of the I job, this sum is minimized, okay? And there is a table here with an example. I'm not going to do it because numerical example, not interesting. But you can fill it in if you want to get some intuition. And when I looked on the slide preparing to record this section, I didn't remember how to do it. So the right thing to do when you don't know how to do something is to look on an example. The simplest possible example is we have two jobs. First job has a processing time P1 and wait W1. Second job has processing time P2 and wait time PW2. And now there are two possible ordering. Either the first job is first or the second job is first, right? If the first job is first, then the first job doesn't wait. That's good. But the second job has to wait time that is the length of the first processing time. So the price overall is going to be what's written here, right? Similarly, if the second job is first, then the second job doesn't wait. So the total waited for time is 0. And the second job has to wait the length, the first WJ1 has to wait the processing time of the second job. So we get this. So this is just this. So the two prices. And of course, we are trying to minimize the processing time. So we just need to compare those two quantities and decide which one is smaller, right? So is it P1W2 or P2W1, right? Which one is which? To this end, we're going to divide both sides by P1 and P2, right? So we get W2 over P2 and W1 over P1. And we need to compare them, right? If we kept the ordering, right? So if this is smaller here, then this is smaller here, which means that we have to prefer the first job. Okay, so first job first. Okay, so what are we going to do? Let's compute this ratio for all the job, omega I, right? Just WI divided by PI. The right way to think about it, as I mentioned, if WI is the payment we get for the I job, then WI over PI is the price we get paid for 1 unit of processing time. Okay? And now all we need to do is sort them in decreasing order, right? This is important here, right? Here we prefer the second job if this quantity is smaller than the first job, right? Then we prefer to put the first one first. Namely, we need to schedule the job in decreasing order of the omegas. Right. And schedule the job by this order. So this is the right ordering. Now we need to prove that this is correct. The proof of correctness is exactly the same argument we had before, right? You just need to argue that there must be, if there is an inversion, there must be two jobs next to each other in the optimal solution that are inverted, and then argue that if you swap them, then the price decreases, the total wait time decreases, and this follows immediately from this calculation above, essentially. So we are done. So that solved this exercise. Okay.